So hello everybody. So today what we'll be discussing about motors. So as you can see in the slides, like these are all the equipments or all the things that we use in day-to-day life, and these all require some motor. Like the desert fan, the desert cooler that you are seeing, that requires a motor. The normal table fan that you see in the screen, that requires motor. So motor is something that we supply electricity to and it starts rotating. So this is Rajna's teaching aid for an electric motor. So what it consists of is a copper coil. So this copper is actually a conductor of electricity, and there's an insulation of over the copper coil, and it prevents the coils from interacting with each other. So this is a conducting copper coil. The another thing over here is, as you can see, is a bar magnet. So this is the north pole and this is the south pole of the bar magnet. So if you are done with the magnetic chapter, so you must understand that this is a soft iron core, and by putting this bar magnet over it, I am making this hole as a north pole and this hole as a south pole. The another thing I have got over here is the two terminals. So while I was winding this wire, obviously the two terminals were there. So one in this terminal and the other end is this terminal. So there's this next thing that is called a battery eliminator. So all the electrical appliances that you see at home are based on some very large amount of current that comes at your home. So but this is a small equipment that won't require such large current. So this battery eliminator basically reduces the current, or it changes the form of current as well. We'll discuss that later. So all the huge current that is coming from your meter is reduced by this battery eliminator. So what I am planning to do over here is I'll be putting some electric current in the terminals of this teaching aid. I'll be making a current of 2 to 4 volts. Better not increase the current more than 4 volts. So putting this black over this black terminal and red over this red terminal, and I'm giving it a current. So now you can observe, if I give it a little jerk, it starts moving, and it starts moving pretty fast. So if I reduce the amount of current, you can feel that the motor is getting slower and slower. If I am increasing the amount of current, it is increasing. So now I am switching off this thing and there is no more rotation. So we'll try this again. But now what do you think has to do this with this magnet over here? If I take this magnet out, you can observe that this motor is no longer rotating. So it has to do with two things. One is this current that I am supplying, because when I switched off the current, it was not moving. And one is because of this magnet. As soon as I am putting this magnet again, it is starting rotating. So this was the demonstration of an electric motor. So can you make this electric motor at home? So let's discuss how to make this electric motor at home. So there are some basic things that you'll be needing. So here's the first thing that you'll be requiring. This is called a copper wire. So I am having a roll of copper wire. So I'll be needing this about like a 2 feet copper wire, and it has a dimension. It's a normal copper coil, but it is insulated, as you can see. So to remove its insulation from the ends, I'll be requiring what is called a sandpaper. So you can use this sandpaper. It actually has some the crystals of glass over here, and glass, as you know, is sharp. So like just scrubbing this over this removes the coating of the insulation over here, and it's a conducting thing. So the first most requirement is we have a conducting copper coil. The next thing we'll be requiring is this magnet. So as you can see in the teaching aid, we were having this bar magnet. So instead of a normal bar magnet, I'm using this neodymium magnets. The reason I'm using this neodymium magnets is because they are pretty strong. So now you can see that it's having a strong force of attraction or repulsion between them. So these are pretty strong magnets. Another thing I'll be requiring, as I was supplying electricity over it. So to supply electric current, I'm having this Panasonic battery over here. So this is about 1.5 volts battery, and the reason I'm taking this big one is so that my motor can run for a longer time. Instead of this, you can use some other batteries like that you can get in market, but the motor won't last long. So I'm using this big one so that I'll supply more current through the motor. So for connections, I'll be requiring these safety pins. So you'll be requiring about 2 of them, and finally I'll be requiring a normal tape to make all the connections. the couple of instruments that tools that you'll be requiring, one is this wire cutter and one is this screwdriver. So this was the teaching aid of the motor, and we'll try to replicate this whole thing into something that we can make at home. So first things first, this is a copper coil. So I have a copper coil over here, and let's make something like this. I'll wind this copper coil on the back of this screwdriver. I'll be turning this over here. So make sure that you make about 8 to 10 turns, because this is a thick copper wire, so less number of turns can be effective. So make sure to wind up about 10 times. I have wound it 10 times, and using this wire cutter, just cut off this end. It becomes something like this so that it can rotate on its axis. So after this, you have to take this sandpaper and rub off its end. So I've already done this using this, and its ends are already rubbed and it can rotate on this particular ends. So this is done. So I have this copper thing done. My conductor is there and I have wound it. And now the next thing that I'll be requiring is this current source or the voltage source. So I'm using this battery over here, as I was using battery eliminator in the earlier case. So now I have to supply current through this both these ends. So what I'll be doing is I'll be using two safety pins. So here are the two safety pins I have used. So I'll be putting this safety pins at this end and the other safety pin at this end, and using a cello tape I'll be fixing this at both the ends. So now as you can see, I have wound these two safety pins over here. So basically this one is the negative terminal and this one is the positive terminal. So I've extended this negative and positive terminals over here, and if I adjust this over here, it will be like I'm passing current from this direction to this direction in this copper coil. So now that you have completed till this step, we have completed till this step, so it particularly resembles something like this as I have shown. It's like this. So from the very first view, you can see one of the things is missing in this. So can you identify what is missing? So this one is missing in this, and that is what we say a magnet. So similarly, to complete our motor, we'll be requiring two magnets. We'll be requiring this neodymium magnets. So I'm just pasting it magnet over here. So just to make sure it doesn't escape out, I'll be sticking some. I'll be sticking some this tape over it. So now as you can see, I have adjusted this magnet over here, and now I have these two terminals. So now our motor is almost ready. So I have this current source, this voltage source. I'm supplying positive and negative terminals through it. I'm having this magnet over here, and I'm having this copper coil. So just for the definitions, a motor or even the generator that you will study in later classes, a motor is something that converts electrical energy into mechanical energy. So electrical energy is something that you cannot see actually. Like electrical energy can be converted into heat energy, light energy, and this rotational energy, so that you can see. Because see, right now you cannot see any motion in this, but it still has energy, right? It has some electrons moving inside it. So it has some stored energy, and I'll be using this stored energy. Basically, I'll be converting the stored energy into a mechanical energy. Let's try and fit this copper coil into it. So you have to be a little careful while doing this. So now here it is. This is a dynamo. This is the prototype of my motor. So let's see what happens. So by giving it a little jerk, you can see that it starts moving. So this is what our homemade motor is. I have this magnet, I have this copper coil, and I am supplying electric current through it. So now you can see that this thing is moving. So what do you think I can do to increase the speed of this motor? So What about I bring some two more magnets near it? Do you think the magnetic field will increase? So here it is. As I'm bringing a new magnet near it, the speed is getting increased. And the reason is the below magnet, the front face is a north pole, and the magnet that I am bringing above is a south pole. So all the magnetic lines that are coming from north pole are ending in the south pole. So basically the orientation of magnetic field lines is more. As I am taking it away, the speed is reduced. So this is a demonstration that basically depicts that it's not only the current that is responsible for the motors, it's also the magnetic field. So this was the model for the homemade dynamo. Dynamo as also you can say of this motor. So hope you understood the basic concept of this the electric motor, and in your classrooms you must study about the Fleming's left hand rule where this one is applicable for, and you can experiment with this particular motor. Again, you can increase the number of turns and see whether the amount of rotation is increasing. You can, as I'll show, you can change this magnets, you can change the terminals as well. So this was about the model of electric motor.
If you want to see more stuff like this, please subscribe our channel Sarjana Learning by Doing.